மாணவர்களின் சாதனையை போற்றும் SNS 25ஆம் ஆண்டு வெள்ளி விழாவை கொண்டாடும்
So good evening. So welcome to my next lecture series on control systems. So in today's class, now we'll be discussing the critically damped system. So in our previous class, we have discussed about the underdamped system, the response of underdamped system, and in today's class we are going to discuss about the response of a critically damped system. So a system is said to be critically damped when its damping ratio zeta is equal to 1. So when zeta is equal to 1, the system is said to be a critically damped, and most of our robotic system belongs to this category. So now again we will consider the general form of a second order system, which is given by C of s by R of s is equal to omega n squared divided by s squared plus 2 zeta omega ns plus omega n squared. Now it is a critically damped system, which means we have to apply zeta is equal to 1. So which implies the equation now it becomes C of s by R of s is equal to omega n squared divided by, so s squared plus zeta is 1, so we get 2 omega ns plus omega n squared. Now which I can write it as omega n squared divided by, so this is the form of a plus b the whole square. So it is a plus b the whole square, so it is s plus omega n the whole square. And now again we consider for a step input. So for a step input, your input R of s is equal to 1 by s. So now our C of s is equal to, now it is omega n squared divided by s into s plus omega n the whole squared. So again applying partial fractions, we have to split it, apply partial fractions. So we split the equation, that is C of s by R of s, which is omega n squared divided by s into s plus omega n the whole squared is equal to, it is a divided by s plus b divided by s plus omega n the whole square plus c divided by s plus omega n. This is by applying partial fractions. Next we cross multiply it, so we get omega n squared is equal to a into s plus omega n the whole squared plus b into s plus c into s plus omega n. So again substitute s is equal to 0. Now we get our a is equal to 1, because this term becomes 0, this term also becomes 0, so a is equal to 1. Next, comparing coefficient of s, comparing the coefficient of s on both sides of the equation. So we get here it is 0 is equal to, now here we get in terms of a, that is a times 2 omega n, because it is s plus omega n the whole squared, which we can write it as s squared plus 2 omega ns plus omega n squared. So the coefficient of s is 2 omega n plus b, and then plus c times your omega n, which is nothing but c omega n. So we'll just keep this equation as such, because c is also unknown. So in order to find the c, compare coefficient of s squared on both sides of the equation. So when you compare coefficient of s squared on both sides, we get 0 is equal to a plus c, which implies c is equal to minus 1. So now we got the value of a, we have got the value of c, now we can find the value of b. So it is 0 is equal to, a is 1, so 2 omega n plus b minus omega n, c is equal to minus, so minus omega n, which implies b is equal to minus omega n. B is equal to minus omega n. So substituting in the above equation, now we get our C of s by R of s is equal to, it is a divided by s, a is 1, so 1 by s, b is minus omega n, so minus omega n divided by s plus omega n the whole squared
and then minus c is again 1 divided by s plus omega n. Now next, c of t, our response, is equal to Laplace inverse of c of s by r of s, which is nothing but Laplace inverse of 1 by s is 1 minus. So now here it is omega n is constant, 1 divided by s plus a the whole square, so it is t e raised to minus omega n into t. So that's the Laplace inverse of this, minus e raised to minus omega n into t. So which is nothing but our c of t is equal to 1 minus, so our e power minus omega n into t is common, we just take it outside, so it is 1 minus or 1 plus t omega n into t, omega n into t. So this is our final response for a critically damped system. So you can see there are no sinusoidal terms in this, we just have only an exponentially decaying term. So our response for a critically damped system is nothing but it is just a curve which reaches the final value. So this curve, this is your final value 1, so it is c of t versus t. So this curve represents the response of a critically damped system. So hope you have understood. So thank you for listening. Thank you very much.